Yeah, right. I am going to get this done tonight by tomorrow morning. Plus the headaches, I thought they were going. Holy smokes, right? Questioning the speed of light. Why is it questioning the speed of light? This is not just one thing. This is not just the 4.6 seconds, right, that it takes for the sun to radiate light the distance of its diameter. I think it's an absurdity. There's a lot of things leading up to this, right? The amount of people that keep coming back with this, yeah, old Roma. Listen, old Roma is an absurdity. Now, please pay attention, right? It's cool, isn't it? It's to scale. The moon, that is to scale to Earth. But right now, this is Jupiter and this is Io, okay? This is the moon that is said Roma worked out the speed of light because of a delay in a shadow. Now, this is what happens. So, we've got the sun behind us, okay? So, this is Jupiter. Jupiter's orbiting the sun, it's here. So, Jupiter's orbiting, and we're inside Jupiter, right? And we're orbiting the sun as well. His first measurement, right? We were in our orbit closest to Jupiter. So we had the sun behind us. So we're all orbiting like this, right? He gets a telescope and he waits for Io to come out from behind Jupiter, right? And he takes a reading of it, okay? Okay, whatever. It's just ridiculous. This is in 1676. There's no electricity even, right? So what? He writes down what? Okay, watch. What does he write down? It's ridiculous. But anyway, let's play along for a second. So he writes down, he finds an electronic device and goes, oh, look. So he records the time, right? He does this, I don't know how many times. 6 months later, Earth goes halfway around the sun. So now we've got the sun in front of us. In that 6 months, Jupiter and Io have only moved 1/24th of their orbit because it takes them 12 years, right, to orbit the sun, right? So it's basically Jupiter's hardly moved. In our half orbit around the sun, Jupiter's just gone dink. The argument is, the second time he took the readings with a telescope, so he's looking now and he's, again, 6 months later, we've moved all the way around the sun and he's waiting for Io. Now listen, he's using a telescope to look at Io, right? What time delay will there be? The argument is that in the distance when we were closest to Jupiter, and we've come all the way back round the sun, which would be here, right? It's 150 Ks, and another 150 million Ks, and another 150 million Ks, right? Because we're the opposite side of the sun. The argument is it was 300 million kilometers further away from Jupiter. So when he looked, and Io, there was a delay. How can there be a delay? It's impossible, because he's looking through a telescope. It doesn't matter where you are. I could go 20 billion kilometers away. If my telescope is powerful enough, I'm going to see exactly the same. There is no delay, right? So it's an absurdity. It's ridiculous. So you can write that off. And the other reason is there was no electricity, right? There's no power. Why on earth would anybody in their right mind suddenly decide to want to measure the speed of light coming from the sun? It wouldn't have even been a thought. It wouldn't have even been a thought, right? Because there was no need for any thought of measuring the sun. And the other thing, kilometers didn't come out until 1793. Stop it. And it was 1676. So, he came out with what? It was under 299,000. Rubbish. It was never done. It was never done. Because it's illogical, all right? The end. It's dead in the water. So anybody who's watching this must understand that looking through a telescope, there is going to be no time delay. We're 300 million kilometers further away, so there's a time delay. There is no time delay. There cannot be a time delay. So that is made up, right? Then we've got, you can measure the speed of light putting marshmallows in the microwave and checking out the hot spots, and then and people are believing this, right? The other one that people keep sending me, some guy, Alexa, who tried to discover the speed of light using mirrors and turning something around and slits in the mirrors.
From thevaxsolutions.com. In 1926, Albert Michelson, the German-born American physicist, came up with a method to measure the speed of light to a high degree of accuracy despite the technology not being advanced enough at that time.
That is nowhere near enough. Alexa, how was the speed of light measured using a mirror and turning it really fast?
From Forbes.com. To measure the speed of light, you first bounce the light off of a rotating, 8-sided mirror, and then send it down your tube, with mirrors on each end.
What? So we've got an 8-sided something, right? We send the light down a tube, right? And everybody's going, yeah, and this is how they did it as well. Whoa, what do you mean this is how they did it? Have you looked into these things and analysed what they're saying? This is the problem, right? Everybody's seeing these things and just going, oh yeah, no, and this is how they did it. No, it's not how they did it. Because how do you recreate 299,792 kilometers per second in a mirror and going like this and watching some light? Can't you see this, right? It's like, look at this link. This is how they did it. Look at this link. Stop sending links. Look at the link and read it and try and go through it step by step. It's only then that you personally will realise that these things are ridiculous, right? It's like, the only reason this is happening is because people can't think for themselves, right? You're relying on what you read, right? And then somebody else comes along and says, no, that's not right, me, right? And then everybody goes, no, yes it is. Stop this rubbish. You people need to read what these people are saying. Work out what they're saying. How Roma worked out the speed of light in 1676 using a telescope. You can work it out yourselves. You shouldn't need to keep relying on other people, right? You believe these absurdities because you haven't broken them down step by step. Anybody can do it, right? It all boils down to common sense in the end. Looking at a moon through a telescope from 100 meters or 2 kilometers, what delay is there going to be in time coming from a third object somewhere else? There won't be, because you're looking at the moon, the same moon, through a telescope. Look, I get right up here, I'm seeing that moon. I don't know how far away I go, does it? See, these are the things, but nobody's breaking these individual things down. You're seeing one individual thing and then going, right, no, they proved it. Oh, there it is, there's a proof, see? Dude, read it. Don't keep sending these links with saying that the explanation is there, because it is not there. And these people going, well, why would they lie? Jesus Christ, why would they lie? Read the thing, read the explanations of how they did these things. And then you'll be able to go ask yourself, oh, I wonder why they're lying. Instead of pointing to us conspiracy theorists and going, well, why would they lie to us? Read the stuff yourself, break it down. That's what the brain is for, right? You've got to break these things down. Pi. I said I'd explain it, and I'm going to explain it, right? Pi. It's a mathematical constant, right? A mathematical constant is something, this is for Dave Small, because I use it with basketball, it's because it's a sphere, a circle. This bulb, it's a circle, right? The sun, it's a circle. All of these things are circles, right? And pi comes from things being a circle, because you've got the circumference all the way around. If you divide the circumference by the diameter, you get 3.14, right? and it's a constant. So it doesn't matter this bulb, as small as it is, right, and the sun, as big as it is, if I divide the circumference by the diameter, I'm going to get 3.14. If you divide the circumference of the sun by the diameter, you'll get 3.14. Now this was my point. Those of you that were saying, no, you can't use a light bulb, you were right and you were wrong. I jumped the gun a little bit, but the fact is that pound for pound, right, the sun takes 4.6 seconds to radiate light the distance of its diameter, right? This light bulb doesn't take any time whatsoever, right, to radiate light the distance of its diameter. I mean, we're talking, I mean, this is absolute, right? There's that light there, right? Look, let me turn this off. Got to get this bit out of the way, and then I'm going to come back and I'm going to add scooting. Because this isn't just about speed of light. There's common sense involved in all of this. Right. Here we go. Bang! The whole room is lit up instantly, right? What they're saying though is the sun, if we shrunk the sun down to this size, right, we would see the light go like this. 1, 2, 3, 4.6. It takes 4.6 seconds for light to go like this. Get off, bud. 1, 2, 3, 4. This is my point. The bulb doesn't, right? Yeah, it's the bulb, it's not the same. No, it isn't the same, but watch. Everything lights up instantly, boom! That is absolute, right? There is no travel time. Now my point is, the sun, the size that it is, don't forget, this is only something like 5 centimeters, right? The diameter. The diameter of the moon, the sun, is 1 million, right? 390,000 kilometers. You cannot tell me, nothing is going to convince me because it defies common sense, right? That the sun and a 40-watt light bulb both radiate light at the same speed. I'm convinced that light coming from something like the sun or a light bulb, it is absolute. Bang! When you turn it on, it reaches as far as it's going to reach instantly. The end, right? The more powerful the source, the further it will get, the light will get, but instantly. Bang! Absolute. That's it, right? There's no travel time. It's illogical. It's not a train. So when I question these, let's just do the pi thing again, right? Just to set this thing straight, and then I'll come back later on and go into it. We've got the circumference of the planet of Earth, 40,075 kilometers. The diameter, 12,000. Alexa, what's 40,075 divided by 12,742?
40,075 divided by 12,742 is approximately 3.1451.
Alright, 3.14. Can we see the sun's measurements right there? Alright. Alexa, hang on, sorry Alexa, go back to sleep. The sun, the circumference of the sun is approximately 4,379,000 kilometers. The diameter, as we know, boom, it's 1,390,000. So, Alexa, what's 4,379,000 divided by 1,390,000?
4,379,000 divided by 1,390,000 is approximately 3.1504.
3.150, okay. It is the sun, right? It's not dead set, type fluctuations, right? Measuring it from one day to the next. My point was, right, that a circle, it does not matter how big or how small it is, right? What you do to one, you do to another. So if you've got two circles of like these two, right? If you've got two circles that you're working with, doing any calculations, whatever it may be, right? And you want to bring it down to a smaller diagram so you can build something in your back garden or just work it out on paper. If I want to make this smaller, like 1/10 of the size, right? I divide it by 10. The measurements divided by 10. Then I have to do the same to this, right? And it shrinks. But ratio-wise, they're exactly the same, right? Now with the bulb, admittedly, I was comparing it to the sun, right? But here's the thing. This is the sun's natural state, right? It's 1,390,000 kilometers. That's the diameter. This bulb, its natural state is what? 5 centimeters, its diameter. So I cannot, we call it 5 and a bit, 5.5 maybe. I cannot compare this light bulb to the sun because I would have to increase this bulb size to the size of the sun, right? But that isn't really right because who's to say that the light coming off of this, if it was that big, is going to be the same speed like this? Because right now it lights up a room instantly. There's no 4.6 for its diameter. And I can't bring this down to the size of the bulb because what I do to it, I'm going to have to do to the bulb. And this thing would go, it would disappear, wouldn't it, right? So what can I do? How do we compare the light bulb to the sun, the speed of the light radiating for this, and the 4.6 seconds per diameter, right, to radiate light? It's wrong. So, UY Scuti, the biggest known star in the universe. Alexa, what is the diameter of UY Scuti?
UY Scuti's diameter is 2.377 billion kilometers.
All right, 2.377. Alexa, what is the diameter of UY Scuti?
UY Scuti's diameter is 2.377 billion kilometers.
All right, 2.37 billion. All right, now, Alexa, what's 2,377,000,000 divided by 1,390,000?
2,377,000,000 divided by 1,390,000 is approximately 1,710.0719.
1,710. All right, that kind of. Alexa, what's 1,390,000 multiplied by 1,710?
1,390,000 times 1,710 is 2,376,900,000.
My bad. Alexa, what is 1,390,000 multiplied by 1,710?
1,390,000 times 1,710 is 2,376,900,000.
Right, so it's right. I don't know what I did earlier. So there you go. UY Scuti's diameter is 1,710 times that of our sun's diameter. I mean, jeez, right? You get that? Our sun has a diameter that's in the sky of 1,300,000. Look, And this thing is 1,710 times bigger, its diameter. So, I wasn't going to get this far right now, but we're here. Are you going to tell me that if we had this light bulb, the sun here, and UY Scooty here, right? And they were all off, well, we'd be like, how far? 2 billion something kilometers further away at the starting line. On your mark, get set, go. They all turn on, right? We're to believe that the speed of the light coming off of the three things is going to be the same. Rubbish. It's rubbish, right? What would happen is they would all just go boom, and their light will radiate instantly. Boosh. And then you'd see that the bulb's light might radiate only to, I don't know, say 25 meters, right? The sun's light, our sun's light, if you're on Pluto, you could see it. In fact, you'd see our sun from billions of kilometers away, right? The same as we see stars billions of kilometers away, right? So it doesn't take time to get to these planets. It's 8 minutes and 20 seconds to reach Earth. These are absurdities. It's got to be absolute bang. The bigger an object is, right? The more the bright. Alexa, would UY Scooty be brighter than our sun?
From Tumblr.com. UY Scooty is 340,000 times more luminous than the sun.
So Scooty is more luminous. Alexa, what does it mean if something is more luminous than something else?
The adjective luminous is usually defined as radiating or reflecting light, shining, bright. For more, ask me to give you more definitions for luminous.
Alexa, can UY Scooty radiate its light further than our sun?
Sorry, I don't have an answer for that.
Alexa, which star is the brightest, UY Scooty or our sun?
UY Scooty's apparent magnitude is 11.2, which is 37.9 more than that of the sun.
Right.
Our sun's apparent magnitude is minus 26.7.
So there's a different magnitude. Now, what does magnitude? Alexa, what does magnitude mean when we're talking about stars?
From infoplease.com. Magnitude is the degree of brightness of a star.
The degree of brightness. So a bigger star is brighter, so it will radiate its light further. Isn't it? I mean, they cannot radiate all at the same speed. It's illogical. It is illogical. And Rome is illogical. Measuring the speed of light in a microwave using marshmallows is illogical. And thinking that you can get the distance and the speed of light flicking mirrors round, right, is ridiculous as well. How? How do you recreate 299 kilometers per second, right, to 9,000 kilometers per second in a room with a beam of light? It's ridiculous, right? So later on, I'm going to nut this down even closer. I had to get this out of the way. And that's it for now. Later on, I'm going to come back. It's not just about the measurements, like the kilometer per second and the angle here. It's about common sense as well. And it all starts with Jupiter and Io. It's rubbish. So if that's rubbish, everything is connected. The beginning of the story has just fallen flat on its face. This is my point. It's not just about the speed of light. I'm not just questioning it for no reason whatsoever. There's 100 questions to get into here, and they're all absurdities, right? You can't measure the speed of light with a planet and a moon. It's ridiculous. Right. I must go.